Welcome to this lecture. In this lecture, we are going to be talking about Java sorting algorithm. A sorting algorithm is an algorithm that's put element of a list in certain order. The most used orders are numerical order and lexicogeographical order. Efficient sorting is important for optimizing the use of other algorithms such as search and merge algorithm, which requires input data to be used list. It is also often used for canonicalizing data and for proceeding the human readable output. So first of all, in Java sorting algorithm, we just see the implementations of the bubble sort in Java. So bubble sort here, and yes, the bubble sort also refers to a shrinking sort. It is a simple sorting algorithm that works by rapidly stepping through the list to be stored. Each pair of adjacent items and swapping items if they are in the wrong order. The pass through the list is represented until no wraps are needed, which indicates that the list is sorted. The algorithms get its name from the way similar elements, which is bubble, to the top of the list because it uses compressions to cooperate on elements. It is a compression sort. All through the algorithm is simple. Most of the other sorting algorithms are more efficient for large list. So here you can see the diagram of the bubble sort. We have the five indexed here which are unsorted, and this is the diagram here. So the first step in the diagram, you can see here 5 sorted with 1, sorry, swap with 1. So 1 take the place of 5 and then 5. Means we just go through like 1 and then we have the 5, then 12 and 16. Like you can see here 1, 5, minus 5, 12 and 16. So we just swap our 12 value with 5. Sorry, we have the 5 which is the smaller value than 12. So it is a this swap is okay. So we cannot move the 12 in the place of 5. Then we have 1, 5, 12 minus 5. So we just need to swap this value because 12 is bigger and 5 is a small value. So 5 take place of 12. So now we just see 12 is smaller than 16. So it is okay. Now you can see 1, 5 and 5 minus 5. This is our first step, means we just sort our this data first. Now we have this index, mean this bubble sort is in unsorted form. So you can see here we have the minus 5 which is the bigger value here, which is 5 and 1. So 1 5, this is okay. 5 and minus 5, so minus 5 is smaller than 5, so we just swap this value, and then 5 and 12 is okay here. Now we just go to the another sort. 5 minus 5, so minus 5 is smaller than 1, so you can see here Then again 1 and 5, 12. So these are in sorted form. So now you can see here -5 and 1, 15, 12 and 16. We have the OK value here. So our sort is means our algorithm is sorted here. Now we just see the coding example of the bubble sort. Like here I just create a package which is sorting, and in this package I just create a class which is bubble sort. Okay, and here our this class is created here. Now I just create the logic to the sorted element. Public static void bubble underscore sort means I just use a keyword which is str. This is not a keyword, but I just use str. Now I just define the length, which is n is equal to array, and array dot length, and then after this I just define an integer which is k. Now I just use the for loop for integer I which is equal to 0, and then so I just use the integer m which is equal to n, and then m which is greater than or equal to 0, and then decrement operator, because we are just sorting these values, so it will compare the value with the last value. So now k which is equal to I plus 1, and if array and I which is greater than array and k, so swap the numbers which is I, k and array. Okay, so it will slap the number which is I, k and array here. Now I just print this number, so print numbers and array. Okay, so numbers will be print here. Now I just write private static void and swap numbers. Here integer I, integer j and integer array. Okay, and now I just write integer temp and then temp which is equal to array I, and array which is I here is equal to array. So I just simply swapping the value here. Okay, and array which is j, and the j is equal to temperature, sorry, it is temporary files. Okay, now private static void print numbers And the print numbers here, the integer, which is, sorry, it's an integer where input, and then system dot out dot print, and the print here is input, and input is the I here. And now I just concatenate, sorry, you define the string, which is comma, and here I just use the for loop for integer I, which is equal to 0, and then I, which is less than input dot length, and here I just write I plus plus. Okay, and I just close this code here. Now system dot out dot print line, and the print line here is just a slash n for a line break, and then I just write public static void main, and then string arguments, and integer, which is input, and the input here is the values of the bubble sort, which is 4, 5, 9, 3, 7, 6, and 0 and 1. Okay, and then I just write bubble underscore str and input, and here I just use the for loop for I. So I, sorry, here integer I, which is equal to 0, and I is less than n minus 1, and then I plus plus. Okay, so now I just use this one here, and this is a small I, so I plus plus. Okay, so now here we just complete the bubble sort algorithm here, and now we just check the output for this code. So after this bubble sort, you can see here, first we have the value of 4, 5, and okay, it's 4, 5, 3, 7, 6, 0, 1, 9, and it will sort 4, 3, 5, 6, 0, 1, 7, and 9. So after this sorting, first time sort, second time, third time, and at the last we have the sorted value, which is 0, 1, 3, 4, 5, 6, 7, and 9. So this is a simple example of this bubble sort in Java. So bubble sort has the worst case and range complexity both, like it use the formula which is 0 and n 2. Okay, where n is a number of items being sorted. Means the n is the numbers of items where means it are sorted. So there exist many sorting algorithm with subsequently better worth case or range complexity of the 0 n log n. Even other O means O and 2 sorting algorithms such as insertion sort tends to have the better performance than the bubble sort, and therefore bubble sort is not a practical sorting algorithm when n is large. Performance of bubble sort over an already sorted list because means is a best case in O and N formula, like O and N formula. Okay, so this is the example of the bubble sort. Now we just go to the selection sort, and here I just create, so I just remove this one and save, and go to the class which is selection sort. Okay, so the selection sort is a combination. Wait, I just take the picture of this selection sort. Yes, this is the diagram. Okay, so the selection sort is a combination of the searching and sorting during each pass. The sorted element with the smallest or largest value is moved to its proper positions in the array. The number of times that sort passes through the array is one less than the number of the items in the array. In the selection sort, the inner loop finds the next smallest or largest value, and the outer loop places that value into the proper location. First, you can see here we have 5, 1, 2, minus 5, 16, 12, 2, and 12 and 14. So the selection sort, I just told you that in the definitions of the selection sort, that during each pass the sorted element with the smallest or largest value is moved to the proper positions. I mean, you just simply uh, merge these smallest and largest value together. Like here you can see the 5 and minus 5. So first we just sort this 5 at the minus side, 5 at the first index. You can see here 5 and minus 5. Then we have the 1 value here. So 1, minus 5 and 1. So where no, like there is no smaller value than 1. So we just add the 1 in this index. Then this is okay. Now minus 5, 1. So 12 and 2. So we just swap these values like 12 and 2. So 12 take the place of 2 and 2 plays the take of 12. Now we just come to the 5. So 5 is okay here, and then 16 and 12. We just swap these two values. So 12 and 16, then 16 and 12. So it's swap 12 and 16 and add the last 16 and 14, and the value is swap here. Now we just go to the example of this selection sort. So I just misprint some spelling in selection sort, so this is okay, no problem. So public static integer, and then do selection. So it's selection and sort, and then integer, which is array. Okay, so for loop, So for integer I which is equal to 0 and I is less than array dot length. So array dot length is minus 1 and here I just write I plus plus. So length will be minus 1. Now here I just define the integer which is index, and index is equal to I. For and the for here is for loop here is integer j which is equal to I plus 1 now, and then j which is less than array dot length and j plus plus. Now if array j here and then less than array and indexed, and this is the array index here. Okay, so after this I just write index which is equal to j. Okay, and now integer, so integer which is smaller number is equal to array, and array here is indexed. So array and then index which is equal to array and I, and then array here is I which is equal to a smaller number. Okay, and at the last return array. Okay, so here I think I just did a mistake here, so I and this is j. Okay, so j and j here. Now after that main method public static void main, and then strings and arguments. Now integer array number 1 which is equal to 20, 30, 45, 35, 4, 5, 6. Okay, and then integer and array number 2 which is equal to do selection sort. Okay, and then it will print this array. Okay, so print array number 1, and after that for loop, so for integer I array 2 and system dot out dot print line, and the print line here is I, and system dot out dot print line, and the print line here is comma. Okay, now we just check the output. So here it is showing some error, and I just check public static void main. So I just remove this bracket and one bracket from here, and now I just check the output. So you can see here 4, 5, 6, 20, 30, 35, and 45. So these are our sorted array, which is the selection sort. You can see here 4, then 5, 6, 20, 30, 40, 35, and 45. So this is the selection sort in the Java. And now we just go to the implementation sort. So here I just click the new and class, which is, sorry, insertion sort. So it's insertion sort. Okay. So insertion sort is a simple sorting algorithm in Java. It's built the final sorted array one item at a one time. It is much less efficient on large lists than other sorting algorithms. The advantages of the insertion sort is it is very simple, efficient for small data sets, and it is stable, like it does not change the retrieve order of the elements with equal keys. And in place like only requires constant inputs of additional memory spaces. Like insertion sort iterates through the list by consuming one input items at each repetition and grow a sorted output list. On a repetition, insertion sort removes one element from the input data, finds the locations it belongs within the sorted list, and inserts it there. It repeats until no input elements remains. We see the diagrams of insertion sort, and here you can see at first step it's swipe the value with 5 and 2, then 4 with 5, then 6 with 5, and then 1 with 2, and then 3 with 4. So at the last we have the sorted form of the insertion sort. Now we just see the coding example of the insertion sort. So we just simply create a class which is the name of insertion sort, and then public static void directly to the main method, and string arguments, and here I just define the integer. So our first integer is array number 1, and which is equal to the indexed value of the array, which is 5, 60, 10, 23, and 12. Okay, and at array number 2, sorry, at array number 2 we have do insertion sort and array number 1. Okay, now for int I and array, which is 2, and then system.out.println, and the print line here is I, and then system.out.println, and the print line here is comma, and afterwards we just go to the public static integer, and then do insertion sort and integer here and input. Okay, so do insertion sort, take the input here, and now integer temp, use for loop for integer and integer I, which is equal to 1, I is less than input dot length and I plus plus. Sorry, it's I plus plus. Now I just use for loop for j. So j is equal to I and j is greater than 0 and j minus minus. Okay, and here I just use if input j, which is less than input j minus 1, and then temp file. So temp is the input, which is I just call the j here, and then input j, which is equal to input j minus 1, and at the last I just write input j minus 1, which is equal to temp. So I just swap this value with the temp, which is equal to input j. So I just take the input j as a temp, then input j as a input j minus 1, and then input j minus 1 is equal to temp. So I just swipe these values and then return input. Okay, now we just check the output. So you can see here, like we have this output, and this is not the output because I just forget to write the main. And now I just execute this program, and here you can see first sorted element, which is 5, then 10 and 10, then 12, 23, 60. So we have this output for our insertion sort, and now we just go to the quick sort. So this is a quick sort here, and you can see the quick sort or a partition exchange sort is a fast sorting algorithm in Java or any language, which is using dividing and conquer algorithm. Means quick first quick sort means quick sort first divides a large list into the two small sub lists, the low element and the high element. Quick sort can then recursive means recursively sort the sub list. So some steps to implement the quick sort, which is choose an element first and then call it pivot. So first of all, you can see here we have the pivot value, which is 5 from the list. So generally pivot can be the middle indexed element, means this will be the middle element, like we have the 9 element, so this is our middle element. Okay, so now recorder means recorder the list so that all elements with values less than the pivot sum before the pivot, while all elements with values greater than the pivot comes after it. Like equal values or equal value can go either way. After the partitioning, the pivot is in the means pivot is in its final position. This is called the partition operations. So recursively apply the above step to the sublist of the elements with smaller values and separately the sublist of the elements with the greater value. Now we just see the divide and conquer rule in the implementations quick sort. We have the pivot 5 and we just swipe this value with the 4. So 4 comes here, and then we just take the two values, 4 swipe with 7 and 8 swipe with 2. So after that we have 3, 4 on the place of 7 and then 2, and then we just divide 7 with 5 and 5 with 8 with 5. So afterwards we have 7 with 1 and 8 with 5. So 5 and 7. So 9. After that we have the pivot value, so we just simply swap this pivot value with 5. So we have 3, 4, 2, 1, 5 and the pivot value which is 5 here. Now we just go to the example of this quick sort, and it is quick sort. And now here I just write the class which is the quick sort and private integer which is array. And then private integer which is length. Now public void and sort, and then integer here, and then I just write input array. Sorry, it's input array. Now if input array which is equal to null, sorry, it's null, and it is the OR operator to the input array dot length, okay, which is equal to 0, and it will return us the value, and afterwards we just go to the this array which is equal to input array, okay, and length which is equal to input array dot length. So we just take the length is equal to input array length and then quick sort, and the quick sort here is 0 and length minus 1, okay. Now here private void and quick sort, okay. and here I just write integer which is lower indexed, integer which is higher indexed, and then integer I which is equal to lower indexed. Okay, and integer j which is equal to higher index. Okay, now we just calculate the pivot number, means I am taking the pivot as a middle index number here. So int pivot, so it's a private, so pivot which is equal to array, and array here is lower index plus higher indexed, okay, minus lower indexed, okay, which is divided by 2. Now I just divide into the two arrays. So while I is less than or equal to j, and here I just take the each iterations, we will identify a numbers from left side which is greater than the pivot value, and also we will identify a number from right side which is less than the pivot value. Once the search is done, then we exchange both the numbers. So here while array, and array here is I, so which is less than pivot, and I plus plus here. Now while array I which is greater than pivot, and j minus minus here means j is a decrement here. So if I is less than or equal to j, so exchange numbers I and j, and here I just simply move the index to the next position, so I plus plus for the both the sides, so that's why j minus minus. So here I just write if lower, lower indexed which is less than j, so I will just simply call the quicksort method recursively, and here I just write quick and quicksort which is lower indexed, and the lower index is j here. Now if is I is less than higher indexed, and the higher index is quick sort, and I and higher indexed, okay. So I will just call the quicksort method recursively here, and afterwards you just go to the, so it is higher index, and now we just go to the private void exchange numbers. Okay, and the integer I here and integer j here. Now we just swap the values. So int temp, which is equal to array I, sorry, it's array I, then array I, which is equal to array j, and then array j, which is equal to array I. Okay, sorry, temp. Now public, sorry, it's array j is equal to temp. So public static void main, and then string arguments, and here my quick sort, and the object which is shorter, which is equal to new, and we have the class of quick sort only. Quick sort which is equal to new quick sort. Okay, integer which is the index of input, which is equal to 20, 63, 2, 1, 9, 4, 5, 6, and sorter dot sort, and the input here. And now system dot out dot print line, and the print line here is I, and then system dot out, sorry, it's system dot out dot print line, and the print line here is nothing. So our code is complete here. So here we just remove some errors, so which is equal to, and create the local variables for the integer index array, and here I just misprint the semicolon, and now here create the local variable for I. Sorry, so I just remove this character for I here, and now I just run this code after removing all the errors, and you can see here the sorting form of this algorithm is 1 2 4 5 6 9 20 and 63. So these are the some algorithms in Java sorting.